Bismillah, Bismillah, au nom d'Allah.
Good afternoon, learners. I hope we are good. Welcome to our lesson today. It's mathematics, class 7, and we are in lesson 1. And in our lesson 1, we are doing recurring decimals. So we find out that sometimes in division, some digits repeat without ending. Such decimals are known as recurring decimals. And then a dot is placed above the digit that recurs. And in this case, because we have the examples, we are going to see whereby we have one digit repeating itself, whereby we have two digits repeating themselves, and so forth. To begin with, we are going to do example 1, then we proceed down to example 2, move on. So example 1 says, convert 1/9 into a decimal. Convert 1/9 into a decimal. So you just work out the division, then you identify the number or the digit that is repeating itself. So 1/9. That means that you're going to take digit 1, you divide by digit 9. You find out that 9 won't go into 1. So what do? You put a 0 point, then you put a 0 here. Then your 9 goes into 10 once. So 9 goes into 10 once, you get 9, subtract, you get 1. You still find out that 9 won't go into 1. So what do? You add another 0, still 9 goes into 10 once, you get 9, you subtract, you get 1. Again, 9 will not be able to go into 1. What do? You add another 0, then again 9 goes into 10, 1. Get 9, subtract, you find that you're going to get 1. And in this case, you're going to get a pattern of a digit that is repeating itself. Each and every time you're trying to divide, you're going to get that 9 will be going into 10 once, you subtract, you get 10, again 9 goes into 10 once, subtract, you get 9. And you find out that the digit 1 it's going to keep on repeating itself, such that if we were to have that answer, it would have been as long as possible, whereby you could be having 0.1111, then the digit 1 keeps on repeating itself. And in this case, we say that the number and the digit that is repeating itself is actually shown by use of a dot. So we find out that in our division, 1/9 is only digit 1 that is repeating itself. So what do? In your answer, you say that it will be 0.11. Remember, I've said is the digit that is repeating itself, so you put a dot up there to show that in the division, 1/9 is only digit 1 that is repeating itself. It's very clear, it's very simple, brought about by just division. Just divide and identify the digit that is repeating itself. Let's move on to our example number 2. Our example number 2 says, convert 1/6 into a decimal. Convert 1/6 into a decimal. Just the same case with example 1. We're told convert 1/6 into a decimal. So you're going to have 1/6 here. That means that you're going to take 1 divided by 6. 6 won't go into 1. Put a 0 up here, point, then you drop the 0 down there. Then you divide, you find out that 6 will go into 1 once. 6 will go into 10 once. So that gives you 6, subtract, gives you 4. 6 won't go into 4. So what do? You add a 0 here to make the 4 40. Then you move on with your division. You find out that 6 goes into 40 6 times. So 6, that gives you 36, subtract, you get 4, add a 0 to make it 40, and again 6 goes into 40 6 times, that gives you 6, subtract, gives you 4. Again, add a 0 on the 4, that gives you a 40, How many times? 6 goes into 40 again, 6 times, that gives you that 6, subtract, get 4, and you keep on singing the song. You keep on repeating the 6 on the upper part. So what do we identify in this case? When you look at our example 1, that is 1 divided by 9 is different compared to 1 over 6. We find out that here we are going to have 0.1, but the digit 1 is not the one that is repeating itself. The digit that is recurring in this case is 6. So 6, 6, 6, and we're going to have as many 6 as possible. So what do? You write 0.1. The digit recurring itself is 6, so we note it up there. So in this case, our 1 over 6 as a recurring decimal will be written as 0.16. The 6 is repeating itself. We move on to our example number 3. Our example number 3 says, convert 3 over 22 into a decimal. Convert 3 over 22 into a decimal. 3 over 22. This means it's 3 divided by 22. 3 divided by 22. 22 won't go into 3. So what do? You put a 0 up there and a point, then you drop the 0 there. This becomes 30. 22 goes into 30 once. So 22 goes into 30 once. That gives you 22. Subtract, you get 8. Then 22 will not be able to go into 8. What do? You add a 0 here. Then you work out how many times does 22 go into 80. 22 goes into 80 3 times. That one will give you 66. Because if you say 4 times, then that one will give you 88. Remember, we have to get either exactly to this number here or just slightly before it. So we won't use 4. In this case, we are going to use 3. We are going to get 66. When you take 80, subtract 66, you get 14. You find out that now 22 would go into 14. What do? You add a 0 here. That becomes 140. Then you take 140, you divide it by 22. 140 divided by 22. 22 would go into 140 6 times. That one will give you 132. 140 subtract 132 will give you 8. So in some sort, because we are now in our third example, in some sort you are now starting to see a pattern that is trying to appear. We have a pattern that is now trying to appear in some place here. This one compared to this. We have a pattern that is now starting to form itself there. So let's move on and see what we're going to see. To get 22 would go into 8. So what do? You add a 0 here. That becomes 80. And again, 22 goes into 80 3 times. That gives you 66. You subtract 80 minus 66, it's going to give you 14. 22 to go into 14. So what do? You add a 0 where we have 14. That gives you 140. And again, 22 goes into 140 6 times. That gives you 132. Subtract, that is going to give you 8. Again, if you wish, you can continue, but if you have identified your pattern, well and fine. So you find out that now here, we are going now to be repeating 80, 66, 80, 66, 80, 66. So we have already identified our digits that are repeating themselves. In this case, our answer, if we want to proceed, our answer would have been 0.136, 36, 36, 36, and 36 keeps on repeating itself. So because we have identified our digits that are repeating themselves, then our answer will be 0.136. 1 is not repeating itself. The only digits that are repeating themselves is 3 and 6. So we don't have 3 and 6 as the only digits that are repeating themselves. So our answer will be 0.136 and 36 are dotted because those are the digits that are repeating themselves. We move on to our example 4. And our example 4 serves as our last example, where you're told convert 4/15 into a decimal. Convert 4/15 into a decimal. So 4/15, that means that you're going to take 4 divided by 15. You take 4 divided by 15. Now 15 won't go into 4, so you put a 0 up here, dot, then 0. Then 15 goes into 40 2 times. 15 goes into 40 2 times. So 2 times gives you 30. Subtract, you get 10. 15 can't go into 10. 15 can't go into 10. So what do? You add a 0 here. Then you work now 100 divided by 15. 100 divided by 15. 15 goes into 100 6 times. And 6 times gives you 90. Subtract, you get a 10. So you find out that now 15 goes into 100 6 times. 6 times gives you 90. Subtract, that's 100 minus 90 gives you 10. And like I've just said in the previous example, there comes a point that you are able to get a certain pattern that is now trying to form itself. Like when you check here, we are only going to add 100 here. We are going to add 0, sorry, because 15 won't go into 10. So we have already started forming our pattern. So again now we proceed. At 15 goes into 100 6 times, that gives you 90. Subtract, it gives you 10. 15 won't go into 10. So what do? Add another 0. Divide again. 100 divided by 15, that gives you 6, and here it gives you 90. Subtract, you get 10. So you find in this case, we are now going to be forming a certain pattern. 190, 190, 190. So what we understand in this case, that our answer now ought to be 0.2666, and because 6 keeps on repeating itself, it goes to an extent that it makes it the answer very long. So what do? Because you have identified the digit that is repeating itself, the answer now becomes 0.26. 6 is the only digit that is repeating itself, or rather the digit that is recurring. So you dot it up here. The answer becomes 0.26. Just to wind up, when you're told to work out fractions, remember sometimes in the exam you're told to work out a fraction and say whether it is a terminating fraction or it is a non-terminating fraction. What we call recurring decimals is as a result of non-terminating fractions. So just for you to understand, when you talk of recurring decimals are brought about by what we call the non-terminating fraction. So in this case, non-terminating fractions. So in this case, we can say that the fraction 4/15, because it's giving us a recurring decimal, then we can call it a non-terminating fraction. When you compare it to 1/2, 1/2 gives you 0.5 only. That is a terminating fraction. It's a terminating fraction. So after learning recurring decimals, we are now able to differentiate non-terminating fractions and terminating fractions. I wish you the best. Make sure that you copy the notes. Make sure that you do the exercise that we're going to send to you, because we shall mark the books when we open. Thank you for listening.
Bismillah.